All right, Algebra 1 notes for section 7.7, factoring special products. Now, I know you might be worried about my hand here, but we have a puppy. It's about 6 months old, and its teeth are like razors and just loves to bite. So, anyways, sorry about that. Okay, make sure you put your name, date, period on your paper, label it, so I can give you credit for taking your notes. Okay, so there's a few different patterns that we've actually used before that we're now factoring is kind of backwards from multiplying. So we learned how to multiply polynomials and special products, and now we're going to be using those same patterns backwards. So one of the patterns is a squared minus b squared, and this pattern came from a plus b, a minus b. So I don't know if you guys remember that, but this is one of the patterns. Now, you don't have to memorize this. You don't have to. You could do these problems exactly the way we were doing them last time. So this one comes up a lot. So if you see it, it could speed it up a little bit, but we could just do it the same way we've been doing it. So this is called factoring the difference of squares. Okay, so this is a difference of squares. Squares are when things are squared. Difference is subtraction. This is a difference of squares. And when we were multiplying, we called it the sum and difference pattern. You have the same exact thing, one's plus, one's minus. The middle term drops out every time, and we could use that as a shortcut. We don't have to. It'll work the same way as normal. So example A, x squared minus 25. Now, we could do this the same way we've been doing it. Now, if you notice, hey, this is something squared, what I would do is I'd rewrite it as like, okay, what's squared there, what's squared here, and then I could write x plus 5x minus 5. Okay, if, that's fine, you could do it that way, but we could also do it the way we did before. How do you get x squared? The factors are x times x. How do you get 25? Well, one way is 5 times 5. And when you notice there's no middle term, that should make you think, oh, this should be the same. They should be the same numbers both times. So there's no middle term. Okay, no middle term. And so what that means is when we go to the next step, like we did before, we put x and 5 in. This is going to be 5x. This is going to be 5x. And there's no middle term. So that means there's 0 x's. They need to add up to 0 x's. So that means one's got to be positive, one's got to be negative. Plus, minus. Now, we could check our answer by saying, okay, does this times this equal what we had? Positive 5 times negative 5 is negative 25. So that's good. So that's your answer. And we could rewrite it down here. But that's the same answer I got by using the pattern up here. So I'm fine either way with it. Let's do another example like that. So B, this one's going to be 4z squared minus 1. Now, when you see this, you're like, hey, that's kind of weird. Looks like a trinomial with quadratic, power 2, but there's no middle term. That should make you think maybe it's this. So you could say, okay, well, I'm going to make it look like that. Something, the challenge is, what do you square to get this? And you say, well, what do you square to get 4? 2. What do you square to get z squared? Z. What do you square to get 1? 1. And then you'd say, okay, well, that's 2z plus 1, 2z minus 1. You could do it like that. But we could also do it like, well, how do we get 4z squared? And one way is 2z times 2z. You could also do 1z times 4z, but how do you get 1? 1 times 1. And so then we write our binomials, 2z, 2z, 1 and 1. That gives us 2z. That gives us 2z. Now we need 0z though, right? There's no middle term. 0, z. So one's got to be positive, one's got to be negative. Plus, minus. And you get your answer that way. Is positive 1 times negative 1 is negative 1. So we can check our answer like we've been doing. Now, you could use the shortcut kind of pattern if it fits that pattern. The other question you might have is like, well, does it matter if we put the minus first and the plus? It doesn't, because they're exactly the same. So you could put 2z minus 1 and then 2z plus 1 if you want. That's the same thing. Okay? So that's one of the special products. The other special product has the pattern like this: a squared plus 2ab plus b squared. And we've seen this pattern before when we were multiplying. This comes from a plus b squared, which is the same thing as a plus b times a plus b, right? So, and even back when we used this pattern the other way, I kind of wasn't a big fan of it. I feel like it might save you a tiny bit of work, but if you mess it up, you're going to get the wrong answer. So, I mean, I kind of feel the same way here. I kind of think this pattern is worth it to me. I think it saves work. This pattern, not so much. So on these ones, I'm just going to do these the way, I'm not going to treat them special. I'm just going to do them the way we did them last time. So now this is called factoring perfect square trinomials. Okay, perfect square trinomials. So a square is when things are being squared and we're squaring it and we're getting a trinomial. Example A, n squared plus 8n plus 16. Now, I look at this, I'm like, I don't know, that just looks like a normal problem. How do I get n squared, n times n? How do I get 16? Well, there's a few different ways. 1 times 16, 2 times 8, 4 times 4. Hopefully you're getting to the point where you're not having to write all those out before you kind of think of the right pair in your head, because we need to get 8n. Well, that's perfect. It's going to be a 4n and 4n, that gives me 8n. So I write the binomials, and I put the 4's in, and it's going to be 4n, it's going to be 4n, it's got to add up to positive 8n, so they got to both be positive, right? That's it. I mean, I wouldn't use this pattern for these ones. I think the first two, I think that could be worth it. So this is your answer. Now, what we're usually going to do, and what we want to do, is write this answer a little nicer, because since it's n plus 4 times n plus 4, we could also just write it as n plus 4 squared. So that's kind of what we prefer. Okay? Let's do another one. 4x squared minus 12x plus 9. So we're going to make this a little harder. It doesn't have a 1 in front. We need to find a pair of numbers. Now, let's say that we get something that looks like this that ends up not being a perfect square, and we can't use a shortcut. But I think it's a good thing to try when you look at something like this, is to say, oh, let's try 2x and 2x instead of doing 1x and 4x right away. And let's do 3 and 3 instead of 1 and 9. Just try that. And if it falls in one of these special patterns, which a lot of times it will, then you found the right pair. So we're going to get 2x and 2x. We're going to write our binomials. Okay, and then the 3's. So we got 6x and we got 6x, and we need to add up to negative 12x. So they got to both be negative. And so we get the exact same thing in both of them. 2x minus 3, 2x minus 3, which is technically an answer, but it's a little nicer to write it like this: 2x minus 3 squared, because they're the exact same thing, right? Now, the last example, we're going to just look at applying this to problems like we have been in recent sections, solving polynomial equations. And we've added this to the end of a lot of our sections. In fact, we started solving polynomial equations that were already factored before we knew how to factor them. But all of the problems up here, these aren't polynomial equations. They're polynomial expressions. And all we can do is kind of change the way they look, but then we can't find the value for x. But an equation So here's a polynomial, m squared minus 2m plus 1. The equation has an equal sign, a left side, and a right side. Now, if the 0 isn't over here yet, you got to move anything over here and get everything on one side equals 0. And we've been doing these kind of problems, but maybe they just fall into these special cases. So again, this is probably not the pattern I would memorize. I'd be like, oh, okay, well, let's just m and m, 1 and 1. And then we still have the equal 0. Make sure you carry that down. And 1 and 1. And we have 1m. And at some point, you might start kind of doing this stuff in your head. We need to get negative 2m, so they're both negative. Right? Negative 1 times negative 1 is positive 1. Check it. So what we have is we have m minus 1 equals 0. Now we could also write it m minus 1 squared equal to 0. It's not a big deal either way because this isn't our final answer. Usually what we do here is we set each of these equals 0. It's called the zero product property. But they're the same, so like we only need to do it once. Don't list the same answer twice. The answer is m equals 1. If you did it from here, you'd be like, oh, there's one answer that happens twice. We're not going to list it twice though. Okay, so that's your solution to your equation. But it's got to have an equals to begin with. Example B, we'll do one that's a little more strange. But these could happen on these ones up here, and then you would get two answers. You get x equals negative 5 and x equals positive 5. So this one has fractions, but if it's going to work out nice, you might be able to easily do it. Like, how do you get x squared? X times x. How do you get 1/9? 1/3 times 1/3. And I already see, okay, that's going to give you 1/3 x, 1/3 x gives you 2/3 x. So still have that equal 0, 1/3, 1/3. So you got 1/3 x, 1/3 x. It's got to add up to positive 2/3 x. So we're both going to be positive. And so we have x plus 1/3, x plus 1/3 equals 0. You could write it x plus 1/3 squared equals 0. Not as helpful as up here where that's our final answer, so it's really nice. Here it's not our final answer. Set one of them equal to 0. Since they're the same answer, we don't need to do them both. Usually you do them both. Usually you do get an answer here and get an answer here. You usually get two answers. But it's a repeated answer. Now, today's monitoring progress to practice this. It's in this section. It starts on page 398, and we're doing problems 1 through 14 all. If you're doing it in the Student Dynamic ebook online, and I think you got to be zoomed all the way out, which is annoying because you probably want to zoom in so that you can actually read it better. But then when you want to check your answers, zoom out, and there's that little blue play button, and it plays a video showing you how to do the problem from the beginning to end. If anything, you do it just to check your answers. At least just check a couple, just to make sure you're getting them right. And then, of course, any that you get stuck on or you can't finish or you really feel like you might have messed up, definitely check those. But it'll show you how to do it, and then you can figure out what you're doing. But check them at the beginning before you do too many of them and realize you're doing them all wrong. So there you go.